First and foremost, I would like to thank Department of Physics, Namche Government College and Sikkim University to provide this platform to explain the concept of a given topic and provided by our respected teacher C.P. Khatioda for the partial fulfillment of BSc third semester June to December 2020. This video carried 25 marks or sessional B examination. My name is Sanjita Chetri and my roll number is 19NS0145 and my topic is Newton ring experiment. First, I will give a short introduction for this Newton rings. Newton rings is a phenomenon in which an interference pattern is created by the reflection of light between two surfaces. One is a spherical surface and another one is an adjacent touching flat surface. It is named for Isaac Newton, who first studied in 1717. Now I will explain the experiment arrangement for this Newton ring, or we can say its construction. For this construction, we'll take one plano convex lens, and below this we'll take one glass plate out here below this convex lens. So the light will start coming from this source and here we have placed one another glass plate out here at an angle 45 degree in the principal axis of this lens. So the light will come from this source and will impose on this glass plate. Here we have a microscope which is a traveling microscope. We can adjust this microscope according to our requirement. So here is a monochromatic source of light. What does this monochromatic means? It means we have a sodium light or any light source which emits one type of wavelength. Here, for example, we have choose a sodium lamp. When the light come from this source, it will fall upon this lens and will proceed towards this glass plate, which is inclined at an angle 45 degree. It will reflect the rays and it will go down. It will go down and will pass through this area here between these two plano convex lens and this glass plate, the air flame will formed. The air flame will gradually increases, which is called a wedge shape air flame. Air flame is nothing but this is the distance between this distance between the bottom part of this plano convex lens and upper part of this glass plate. So the light will travel from upper part. Here we have eyepiece of microscope. Let us consider this eyepiece of microscope. Here at the eyepiece of microscope, here is a dark fringe, then bright fringe, then dark fringe, then bright fringe. It will start from dark fringe, then bright fringe, then dark fringe, then bright fringe. And this is called the Newton rings. It is called Newton rings because the experiment is done by the Newton. Here we are studying the reflected system. So for this we have to calculate the path difference. For the path difference we have this formula. formula. The formula is given by del is equal to 2 mu t cos r. You can say it's equation number 1. Here for airframe, here we have this setup. Here is plano convex lens, and here is one glass plate. The light ray is coming from the upper part, and some of the part is it will reflected, and it will some of it's transmitted, and similarly some of it reflected and some is transmitted. And this is ray 1 and this is ray 2. Here will be the division of amplitude. Because of this division of amplitude, the one ray is divided into two rays. Here one and another one is 2, and both of these two rays are coherent. Now we will calculate the distance between this ray 1 and ray 2, which is called the path difference. The formula of path difference is given by del is equal to 2 mu t cos r. For airframe, mu is equal to 1, and condition for normal incidence, we are having r is equal to 0, which is cos 0 is equal to 1, and it become the equation 1 become del is equal to 2 into 1 plus t1, which is del is equal to 2t. Here we have the light comes from the denser medium to rarer medium. So here will be introduced the extra path difference, which is we will the extra path difference we will denote it by here it will denoted by lambda by 2. This equation number 2. As we have already discussed that there will be two fringes, there will be two fringes in Newton rings, which is one is bright fringes, which is constructive interference. We are talking about those two rays, those two rays this one and this one, and another one is dark fringes, which is called destructive interference. For bright fringe, we have del is equal to n lambda, which is equation number 3. Equating this to equation and this equation number 3, equating equation 2 and 3, we have 2t plus lambda by 2 is equal to n lambda. This is equation. We will now calculate this one. 2t is equal to n lambda minus lambda by 2. 2t is equal to 2n minus 1 lambda by 2, which is equation 4. Now similarly, for dark fringe, that is destructive interference, we are having del is equal to n plus 1 by 2 lambda. This is equation 5. Equating equation 2 and 5, we get 2t plus, here we have equation 2 is equal to 2t plus lambda by 2. 2t plus lambda by 2 is equal to n plus 1 by 2 lambda. 2t is equal to n lambda plus lambda by 2 minus lambda by 2. 2t is equal to n lambda, which is equation 6. For maxima, for bright fringe, we have 2t is equal to 2n minus 1 lambda by 2. For minima, dark fringe, we are having 2t is equal to n lambda, which is equation 2. I will give this one is equation number 1 and this one is equation number 2. Now we will calculate the diameter of the Newton rings. We have this setup. Here we have plano convex lens, and here we have glass plate. Now let us consider, here is this one is Newton rings. This makes a circle. Newton rings, let us consider this one is radius. Let's consider this point as P. This one is also radius. Here we have this, the radius of this convex lens. We will consider this one is X, and this one is T. This length is T, this one is R. Now the distance between this one is, we are having R minus T. Here T is equal to 0. Thickness of this center point is 0. This R is equal to radius of curvature. T is equal to thickness. Now by Pythagoras theorem, in triangle, this one is A and this one is B, this one is Q, we'll consider this one is Q. In triangle APQ, AP square is equal to PQ square plus AQ square. AP square is equal to PQ square plus AB square. Hypotenuse square is equal to perpendicular plus base square. Now we are having this AP square is radius. We will say R is equal to, and this one PQ is equal to R minus T square. R minus T square plus, and this one is X square. X square is equal to R square minus T square, or R square is equal to R square minus we'll open this one, R square plus T square minus 2RT. This one and this one get cancelled, or X square is equal to T square minus 2RT. We'll give this one is question number 3. Now X is equal to, we get X is equal to T square minus 2RT. Here we have the thickness is 0, so it is 2 is small, almost it's like the 0.01. It is 2 small. The square of this one is no, this one, it's like if we consider this square of this 0.01, then it will get 2 is small, and likewise the thickness of T is very small, and if we will square of this thickness, then we will get the very low minimum value. It's almost equal to 0. So we will neglect this thickness, and we get now X square is equal to 2RT. Now 2T is equal to X square upon 2R. Here X is the radius of this length, so for diameter D is equal to, it's almost like this one, D is equal to 2X. X is equal to D upon 2. 2T is equal to, it will become D square upon 4R. We'll give this one is equation number 4. Here we have for maxima by reference, we have 2T is equal to 2n minus 1 lambda by 2, and we will equate this equation 1 and 4. Equating equation 1 and 4, we get 2n minus 1 lambda upon 2 is equal to D square upon 4R. D square upon 4R for bright friends. This one is for bright friends. minus 1 d square, right, is equal to 4r 2n minus 1 lambda by 2 d square b is equal to over 2r 2n minus 1 lambda. This one is equation number 5. Similarly, for dark fringe equating equation 2n 4, we get, for dark fringe we have already calculate this one, n lambda is equal to d square upon 4r for dark fringe is equal to 4n lambda. Question 3. We can put the value n is equal to 0, 1, 2, any number. Okay, thank you.